Okay, so in this lecture we're going to cover this concept of fractional precipitation. So if we had a solution of two cations, say, so let's say we had a solution of barium and strontium, can we precipitate one without precipitating the other? Which basically means, can we separate? Can we separate the barium and strontium? So if we could precipitate one and it comes off as a solid, out of solution as a solid, and the other one stays dissolved, then we can just do a filtration and we would separate the two, right? So to do something like this, so this would be what's done in mining, for example. If you're mining for a particular element, they're typically going to be in their cationic form, and if you wanted to separate them, then if you can precipitate one and not precipitate the other anions or cations that are in solution, then you've effectively separated one metal from other metals. Okay, so what you need to do is find an anion where you have a very small KSP for one cation and not the other. So for barium and strontium, this would be CrO4 2-. So chromate. So KSP for barium chromate is 1.2 times 10 to the minus 10. KSP for strontium chromate is 3.5 times 10 to the minus 5. So based on that, which is more water soluble, strontium chromate or barium chromate? So hopefully you picked the one that's more soluble, is strontium chromate, right? Because KSP is bigger, that means more of it dissolves in water at this in 1 liter of water than the other one would. You know, so 10 to the, sorry, that's 10 to the minus 5. So 10 to the minus 10 versus 10 to the minus 5. So that's 10 to the 5th, so that's around 100,000. So strontium chromate is about 100,000 times more soluble than barium chromate is. Okay, so what we want to ask then, so what needs to be the concentration of CrO4 2- to cause the precipitation of barium chromate? So basically what you would do is you would take another solution, so maybe it's something like sodium chromate, because sodium cations are generally very water soluble. So you got sodiums floating around in here and CrO4- floating around, and you add this solution to that. So once you have chromate in solution, then the barium will precipitate to make solid barium chromate, and the strontium would stay in solution because it's 100,000 times more soluble. Okay, so if you want to know what the concentration of chromate needs to be to cause the barium to precipitate, so KSP for barium chromate equals 1.2 times 10 to the minus 10. And the concentration of barium is 0.1 molar, right? Did we give you that? No. Okay, so we're going to say we have a solution That is 0.10 molar barium and 0.10 molar strontium. And then what needs to be the concentration of chromate to cause the barium to precipitate. So we just set up the KSP equals concentration of barium times concentration of chromate. So if the barium is 0.1 molar, then what is the concentration of chromate need to be for this to precipitate? So just solve for x. So x equals 1.2 times 10 to the minus 9 molar. So when the chromate concentration reaches 1.2 times 10 to the minus 9 molar, barium chromate will start to precipitate. And so what does concentration of CrO4 2 minus need to be for strontium to precipitate? So we do the same thing. We take the KSP for strontium chromate, which was given. It's 3.5 times 10 to the minus 5. And the concentration of strontium in the solution is 0.1 molar. So what does chromate need to be? So solve for x. 3.5 times 10 to the minus 4 molar. So when chromate concentration is 3.5 times 10 to the 4 molar, then the strontium will start to precipitate as well. So if you wanted to separate the barium and the strontium, you would have to filter off the barium chromate before the chromate concentration reached 3.5 times 10 to the minus 4 molar, because at that point strontium chromate will start to precipitate as well, and then you have a mixture of solids at that point. Okay, so what is the concentration of barium ions in water when strontium starts to precipitate? So what we could do then is take the KSP for barium, for barium chromate, KSP, set that equal to, so what would the concentration of barium be when the concentration of chromate is 3.5 times 10 to the minus 4. So that's the concentration of chromate when SR24 CrO4 would first start to precipitate. So solve for x. X equals 3.4 times 10 to the minus 7 molar. So then if we take the ratio, 3.4 times 10 to the minus 7 molar divided by what you started with, and times it 100%. So that equals 0.00034%. So when the very first strontium chromate starts to precipitate, the concentration of barium at that point would only be 0.00034% solution remaining in solution. So long as you filtered off the barium sulfate before that point, so now you have pure barium chromate. I don't think I keep saying barium sulfate, but you would, so right before the concentration of chromate reached 3.5 times 10 to the minus 4 molar, if you did a precipitation at that point, you would have pure barium chromate solid that you could filter off. And then when you started precipitating the strontium chromate out, There's a little bit of barium left in the solution, so it's going to precipitate with the strontium chromate, so you couldn't get the strontium chromate totally pure at this point, but that's pretty pure because there's only 0.00034% barium still in solution at that point. Okay.